Now that we've found the critical points of our function, we are going to use them by substituting them back into the derivative to find where the function is increasing and decreasing. To do this, I've created a number line and I've marked on the number line with dots our critical points at -3, 0, and 3. To test these critical points, I selected values that are around these critical points. I decided to use -4, -1, 1, and 4. I'm going to take these 4 values and plug them back into our derivative, which was y prime equals 36x over 9 minus x squared. We're going to start with the -4. So y prime equals 36 times -4 over 9 minus -4 squared, the quantity squared. Now when you simplify that, you get -144, which is 36 times -4, over 49, because -4 squared will give you 16. 9 minus 16 is -7, and -7 squared is 49. Now when you divide these, you will get a negative number, and we don't care what that number is, all we care is that it is a negative number. Next, we are going to use -1, which is in between -3 and 0. So we're going to substitute that into our derivative. So we have 36 times -1 over 9 minus -1 squared, the quantity squared. When you simplify that, you get -36 over 64. Because 1 squared is 1, 9 minus 1 is 8, and 8 times 8 is 64. When you divide these, once again, you will also get a negative number. All we care about is that it's a negative number. You'll see that in a moment when we go back to our number line after we find all of these values. So now we're going to use +1. I'm going to plug that in. 36 times 1 over 9 minus 1 squared, the quantity squared. When you simplify that, you get 36 over 64. And when you divide those, you will get a positive number. All we care about is that it is a positive value. And lastly, we are going to substitute in the 4. Y prime equals 36 times 4 over 9 minus, make that minus sign a little bit bigger, 9 minus 4 squared, the quantity squared. That simplifies to 144 over 49, and that will give you a positive answer. So we're going to take these. We have a negative value at negative 4 when you plug it into the derivative. You also have a negative value at negative 1 when you plug that into the derivative, and you will get a positive value at 1 and 4 when you plug both of those into the derivative. Now, using these signs, we'll be able to tell where the function is increasing and decreasing on the graph over which intervals. So the negative sign means that the slope of the graph is negative, so it'll be going downwards. And then we have another negative here, so that means that the slope will continue to decrease, go down. So we'll have something like that. And then here we change from a negative slope to a positive slope because this has a positive number. And then since it's a positive to a positive, the slope will continue to increase. So from that we conclude that the function is increasing from 0 to infinity, and the function is decreasing from negative infinity to 0. There we go.